In this video, we'll see how we can build our RAG agent using LangGraph. So let's start our video by creating a new file, 8_RAG agent.ipynb. Well, for this RAG agent, I'm going to use a file. I have a PDF file that I'll be using. So let me paste that file here first. So this is a stock.pdf file. I'll be using the data from this particular file for this RAG agent here. Okay, so now first of all, start with imports. Import type dict, annotated, and sequence. Now from LangGen core, I'm going to import something called human messages, tool messages, system message, and base message. So import human message. I don't need AI message. I'll need a tool message and a base message and a system message. From operator, import add as add_messages. Then I'll open the model or import the model, import chat Google generative AI as well as the Google generative AI embeddings. Then from LangGen community, I'll import PyPDF loader to open the PDF file. PyPDF loader. Then we'll import recursive character text splitter, LangGen.textSplitter, import recursive character text splitter. Then for the vector database, I'm going to use Chroma, import Chroma. And finally, for the tool part from LangGen_core, I'm going to import tool. Load the credential first. Then I'll load my model here. The model will not be Gemini Pro. I'll remove the temperature for now, but it is going to be Gemini 2.5 flash model. And for the embedding model, I'll be using so model equals to model/Gemini embedding 001. Okay, let me run this. First cell, and the cell is running. Okay, there is some error here. Let me see what the error is. So Gemini 2.5 flash should be correct. Okay, it should not be model name, but it should be model. Rerun it again. Okay, the model is imported. I'm going to copy this, not put it here, but put the PDF file inside this LangGraph folder so that it can be easily accessed by the notebook file present in this folder. So PDF path equals to stock.pdf. So this is going to be my PDF path. And then we'll try to load the file first. So for that, what I'm going to do is I'm going to check if the file exists or not. Path.exist PDF path, but like if it does exist, then I'm going to do PDF loader equals to PyPDF loader PDF path. Okay, this is also running. Now I'm going to load the pages from the PDF path. So load the pages from the PDF. So I'll put it inside our try block PDF loader.load. Let's also print something. So a PDF has been loaded and has a certain number of pages. If it cannot be loaded, then we'll load an exception and then print out our exception here. An error occurred while loading PDF, and then simply raise an exception. So our PDF has been loaded and then it contains 9 pages. Now what we're going to do is we are going to use our splitter here. So text splitter equals to recursive character text splitter. The chunk size is going to be 1000 and then the chunk overlap is going to be 200. That's okay. I'll keep that for now, but you can change the values according to your need. If you want to make smaller chunks, more smaller chunks, then you please reduce the chunk size. And then if you want to overlap some information between chunks, then you increase the value of the chunk overlap. So now let me split the pages. So pages underscore split equals to text splitter dot split document pages. So if we want to see total number of chunks, then we can print it out, and then we can see that we have now divided it into 24 chunks. If we reduce this chunk size to maybe 500, then we should see that the chunk that our chunks are, or the total chunks number should be increased here. So if we keep it to 500, then we go to 60 chunks, but right now I'll keep it to 1000 and then we have 24 chunks. Okay, now we go to our vector database part. So for vector database, I'm going to give a collection name. So collection name is going to be stock market. So we'll try to create a vector store from this one. So vector store equals to Chroma dot from documents. So document equal to page split. For embeddings, I'm going to use my embedding model, and then for collection name, I'm going to use my collection name. And then finally, we're going to see our success message here. But if we run into any kind of exception, then we'll print an exception and then raise some error. So if we run this, it will take some time to be vectorized, but our vector store has been successfully created, means that try block has been executed successfully. Okay, now we'll define our retriever part. So for retriever, we'll do vector store dot as retriever, and we'll define our search type. Search type will be based on similarity, and then the search keyword arguments will be we'll keep it for 3 for now. So the retriever part is also executed. Now we define our tool. This tool will be our retriever tool. It will contain a query of the form string, and then it will again return a string here. Provide a doc string for this. So this tool searches and returns information from the stock market performance report document. Okay, we're going to invoke our retriever using our query. So retriever dot invoke query. So if nothing is found with similarity to query in our document, then we print out or we return no relevant information found. Or if something is found, then we are going to embed this in a list. So for iDoc in enumerate documents, so I'm going to append everything inside this results list here. And then what I'm going to do is I'm going to convert this list in string form. Now we only have one tool which I will wrap inside this list. Then I'm going to bind my LLM using this tool with the help of the function bind tool, and then run this. Now we'll have our class agent state. It will be of type dict. I'll have messages, which will be an annotated sequence of base message. And then here, what we want to do is we want to keep adding our messages. So I'm going to use this add messages function. And then I will define a router function, should continue state agent state. This will return the tool calls if it has. So what it is going to do is check if the last message contains tool calls. So for that, I'm going to see my last message, and then I'm going to return the result tool calls, and len tool calls is greater than 0. Okay, so this is also done. Now what I'm going to do is I'm going to write a system prompt, which I'm going to copy from my source. So this is my system prompt. You are an intelligent AI assistant who answers questions about the stock market performance in 2024 based on the PDF document loaded into knowledge base. Use the retriever tool available to answer questions about the stock performance data. You can make multiple calls if needed. If you need to look up some information before asking a follow-up question, you're allowed to do that. Please always cite the specific parts of the document you use in our answers. So now what I'm going to do next is run this, and then I'm going to create a tool state. And then here I'm going to do our tool dot name, our tool for our tool in tool. So it should be tool, right? Yeah, in tool. Run this again. So this is also running. Now we'll define our LLM agent. So def call LLM. It will contain agent state. It will also return agent state. Agent state object. So function to call the LLM with the current state. So here what I'm going to do is I'm going to make a list of my messages. So list of state messages. Then I'm going to convert this into a system message, or I'm going to append my system prompt as well as the messages that we have. And finally, we're going to invoke our LLM using the combined message that we have. Okay, so this is done. I don't think I need to mention this messages, so I can just do message here. And then what I'm going to do is I'm going to return message messages list of message. Okay, this is also running. Now we create one more function for our retriever agent. So def take underscore action state agent state. It will also return agent state object. So what this function will do is this function to execute tools from the LLM's response. So for this, what I'm going to do is I'm going to check if we contain any tool calls from the LLM. So tool calls equals to system message -1 for tool calls. If there is, then we'll append everything inside results. So now we'll loop through our tool calls. So we'll try to understand what tool is being called here. So print f executing tool name with certain input. So if not the name in tool dict, I'll do tool not found. Or I can just keep it inside a result, but it's okay. I can keep it like this for now, but I don't want to directly append this. So what I'm going to do here is I'm going to do a result equals to tool not found, else I'm going to append this inside the results using the tool name. So t name dot invoke targs dot get query, and print tool result here. Then what I'm going to do is I'm going to append the tool message that we get from the above loop. So here results dot append tool message. So tool call id equals to t eid. What else? Name equals to t name, and content equals to str result. This should be inside the for loop, sorry. And finally, I'm going to print tools executed, and then return the agent state response. Okay, now we build our graph using state graph, agent state. Add our first node, graph.add node, which will be our add node, which will be LLM represented by call LLM function. Then the second node will be add node. The second node will be retriever agent, which will be represented by take action function. And then the first edge will be graph.add edge. Add edge, it will go from start. I've not imported start, I guess. So let me also import start. So the first node will be from start to LLM. Then what I'll do is I'll add a conditional edge. Add conditional edge. This will go from LLM to should continue. And then we'll have two different cases here. For true, we'll go to retriever agent. And then if false, we'll go to end. I'll add one more edge here from retriever agent to LLM. And then the entry point will be from LLM itself. Okay, what's wrong with should continue? Let's see. Okay, the spelling is wrong here. Should underscore continue. Something's wrong here now. Function is not callable. Okay, let's rerun everything from the beginning. So this is running, tool collection is running, this is also running. The tool call is also running. Now the graph is also built. Let me compile the graph. Call it rag agent equal to graph.compile. And then if we print out our rag agent, then we should see our flow here. So from start, we go to LLM. If it has tool calls, then we go to retriever agent, then we go back to LLM. If it has multiple tool calls, we again reciprocate through these retriever agents. And then once our LLM call is complete, then we go to false and then end the conversation. So finally, we'll define a function for running our agents. So def running agent. So we'll use a continuous loop here, and then we'll ask the user for their question. Input what is your question? So if the user input is exit or quit, then we exit the agent, or else we're going to append the user given text into a human message. Then we will invoke our rag agent. Then we'll print the agent response here. Okay, so this is also done. And finally, we'll call this running agent function. Since it was a long code, I hope we don't have any errors here, so we can run the application. Okay, so initially this is being run now. Okay, what do we ask here? So we'll ask what is the document about. Okay, we have an error. Let's see what the error is. I think I found my error here. So this should be inside a list. The system message should be inside a list here. Because if we don't keep it inside the list, then this is not considered as a base message. Let me rerun everything again. Okay, so what is the document about? We still have an error. Let me check again. For this one, I'm also going to edit my retriever agent function. So let me rerun this again and then see if I get any error. So what is the document about? Let's see if we get any error. Okay, so the query is gone, and then we have two different sources from where we're getting result, and then the agent responses. The document is about stock market performance in 2024, specifically focusing on something. Okay, now we'll open this stock market document and then see what this document actually contains. What happened here? Okay, so let me rerun this again and then check. Meanwhile, I'm going to open this document. Okay, so this is our stock market document. It contains some data, and I will be asking question based on this here. So rerun everything again and then see if we can continuously talk to it or not, because I think we're getting some error there. We'll also fix that. Tell me about the EV leaders. Who is the electric vehicle leaders in the market? It should find that the EV leader vehicles are this company here. So the agent response is correctly given, and then we'll ask how much did they gain. So how much did Tesla gain in 2024? So from late 2023 to 2024 gains are occurring in there. So it contains a lot of content here. So it does give me the share price and then the growth as well as the sources as I asked earlier. So yeah, let me go to something else and then ask it. What was S&P's gain? So it should give me that S&P's gain was 25%. Okay, so this is working quite well. So this is how we implement RAG using our LangGraph. Okay, I'll ask it something that is not present in the document, and then we'll see what it tells us. So why does the sun rises in the east and sets in the west? So it should not have any response for this. So it says, I cannot answer this question using the provided document as it was stock market performance and not astronomy. So this is working quite well. I'm going to end the video here. So I hope it implements on your end too. Be careful about the content of this particular function here, because there are too many brackets being involved here. So you might make some error. If you have any questions, feel free to comment down below and I'll try to help you out. And I'll see you in the next video again. Let me exit the system, and then it gracefully exits again. So yeah, I'll see you in the next video.